This is tutorial 8, question 627, part C. We are going to use x0 from question B, where x0 is constructed from a linear combination of c1 v1 plus c2 v2 plus c3 v3. And remember that v1, v2, and v3 are eigenvectors of A. It implies that A times v1 is equals to lambda 1 v1, A times v2 equals to lambda 2 times v2, and A times v3 equals to lambda 3 times v3. Previously, we have calculated lambda 1, lambda 2, and lambda 3. Let's remind ourselves what they are now. The three eigenvalues are 1, 0.5, and 0.2 respectively for the associated v1, v2, and v3. Now we are asked to calculate what happened in xk, where xk equals to ak times x0. So now let's write ak and x0 in the form of v1 and v2 and v3, which is c1 v1 plus c2 v2 plus c3 v3. Now, this is the interesting problem. Let's assume that k is equals to 1 first. And for example, when k equals to 1, what do we get? We have a. So x1 is equals to a times c1 v1 plus a times c2 v2 plus a times c3 v3. Now what happened is that we are going to apply our knowledge that v1, v2, v3 are eigenvectors. So we replace this with c1 1, and then a times v1 is 1 times v1 plus the second one is c2, a times v2 is 0.5, which is the eigenvalue, times v2 plus c3, and the last one is 0.2 times v3. Alright, I'll write it as eigenvalue for you first. c1 lambda 1 v1 plus c2 lambda 2 v2 plus c3 lambda 3 v3. Now let's see what happened in x2. x2 is a times x1, or I should write a2 times x0, okay, which is equals to a multiplied by c1 lambda 1 v1 plus c2 lambda 2 v2 plus c3 lambda 3 v3. Now again, we can see that we are interested in the problem of a times v1, a times v2, a times v3, because we can ignore the scalar. So what do we get? We have c1 lambda 1 a times v1 is lambda 1 v1 plus c2 lambda 2 a times v2 is lambda 2 v2 plus c3 lambda 3 a times v3 is lambda 3 v3. Now we see the pattern now. x2 is equals to lambda 1 square v1 plus c2 lambda 2 square v2 plus c3 lambda 3 square v3. In conclusion, x of k is equals to c1 lambda 1 k v1 plus c2 lambda 2 k v2 plus c3 lambda 3 k v3. Let us remember what is lambda 1 is 1, lambda 2 0.5, lambda 3 is 0.2. So when we power it by k, 1 to the power of k equals to 1. 0.5 to the power of k tends to 0 as k tends to infinity. 0.2 to the power of k tends to 0 as k tends to infinity. Therefore, x of k is equals to c1 1 to the power of k v1 equals to c1 v1 as k tends to infinity. This is the desired answer. Thank you.